All right, we're down at the Farm Progress Show here in Decatur, Illinois, and joined by Rick Rice with AMVAC. And Rick, this SIMPAS system, you're describing it as an inkjet printer kind of for crops, for in the field. Can you explain the concept and what this is?
Yeah, Kelvin, and so I guess the first thing I'd say is that we use software to tell the system where to put chemicals into a field the same way a printer uses software to tell it where to put ink in the page. And so to continue on with that concept, we package the chemicals into what we call smart cartridges, and then they communicate with the system and the prescriptive software so that as the tractor makes a single pass through the field, we've got multiple products and they turn on and off, or the rate goes up and down based on what the prescriptive software tells it to do based on where it is in the field.
So multiple products, that's I guess one difference between this and a current variable rate technology that farmers would have already on their machines?
You bet. And so this is variable rate, and variable rate and prescriptive are just different terms to describe the same process. So what we've done is made it easy for farmers to apply prescriptively multiple products with a single pass, where most systems today are set up to, if they do prescriptive application, just a single product at a time.
Okay, so what does the actual unit on the planter look like and how does it work?
Okay, so what we'll have with SIMPAS, and SIMPAS is not yet commercially available, so it's still being developed, but what it will be is a system that attaches to the toolbar as an aftermarket installation. There's a bracket on the back that holds multiple smart cartridges, and so you'd have bracket A, B, and C. You may have a fungicide in slot A, a nematicide in slot B, and a micronutrient in the third slot there. And so they line up on behind the toolbar. They all feed down through tubes to the furrow, and they deliver those products into the furrow just as the tractor's making that pass through the field.
Into the existing furrow that is already being opened by the planter?
You bet. And okay. So what we're doing with SIMPAS is building on the foundation that we have in application technology with our SmartBox system. SmartBox was designed to deliver a constant rate from one end of the furrow to the other. Even as the tractor speeds up and slows down, it puts a constant rate out. SIMPAS works on a different philosophy, and so what it does is it changes even if the tractor maintains a constant speed all the way through the field, it turns on product only where it's needed. And so the objective is to help the farmer be better steward of his pocketbook and the environment. If he puts chemical out in an area where the problem doesn't exist, it costs him money, and no farmer likes to spend money when he doesn't have to. And more importantly, he's putting chemicals into the environment and it's not delivering a benefit. And so society at large says, why do that? The farmer has the same objective, and so this is a system that makes it easy for him, as I said, to be a good steward of his own money and the environment at the same time.
Okay. Can you give some examples of situations or scenarios where you see this being an obvious or kind of the first application where you're going to see farmers adopt it?
Okay, so I don't know if you can see the whole screen here, but what we've got are different colored zones in the field. Those represent what we call underserved or unmet needs that exist in a field today. So, and they're problems that occur year after year in the same spot in the field. They are spatially distinct problems, and that's different than a herbicide where you're going to have weed pressure throughout the entire field. So we're talking about problems like nematodes, maybe disease, or micronutrient deficiencies. All of these are problems that can be addressed with low-rate products that can be carried on the back of a planter and then just applied only where the problem exists, but as the tractor passes through that management zone into an area where it doesn't exist, you turn it off. And that's what's represented here. So if you watch, well, we'll see here. There's nothing coming out now, and as he passes into a colored zone, corresponding product comes out of that color. He's going to pass out of that zone. Now he's in 2. You've got 2 products coming out. He passes out. Now he's not spending any money. He's going to enter the red zone here, which represents fungicide. And so it only puts the product out that you need where you need it.
So do farmers have the data needed to print at this resolution in the field, or is that an obstacle to this technology?
So that's a great question. So Today, the biggest majority of fertilizer is put out prescriptively or variable rate. Generally, that's an agronomist that develops those management zone maps that tell the spreader truck what to apply where. So same principle, spreader truck driver just drives through the field and software tells the fertilizer how much to put where. Crop protection chemicals historically aren't applied that way. Most of the fields that get a chemical treatment, we start in one corner, we work all the way across the field, and it's a uniform rate all the way across. We need agronomists to help develop prescriptions so the farmer will know what to do. So how does that happen? Well, we can sample for nematodes, but it's not based just strictly on a soil sample, maybe like fertilizer would be, but we look at what's the soil, what does the sample say, where have we got high populations? Then we'll overlay that with a soil map, and then we'll also lay in a third layer of yield data and say, all right, where we got a high population and it's sandy soil, and we see a pattern of lower yields in that spot, probably a pretty good hypothesis now that we've got nematodes there. Let's treat it with a nematicide. And then the same thing, using the similar philosophy, we go over here to an area and we see yields that are diminished, but it's maybe on heavy soil, and we know that's in an area where water stands. That's probably not a nematicide treatment that's going to go there. That's probably going to be a pythium spot. So we look at what's going on in the field. That generally takes boots in the ground, and so we believe rather than the farmer doing that all the time, he's probably going to have a trusted advisor, agronomist, consultant, you call them different things, but somebody will work with the farmer to develop the prescription so that, as I said at the beginning, the mission is to make it easy. Someone feeds the data into the controller software, and the farmer just has to drive through the field, and then he gets an information that tells him, hey, there's a problem, look at it. Otherwise, he can be focused on planting.
Okay. What kind of resolution do you see it having, or how do you describe how specific or accurate it can be?
Okay. So I think that'll be an evolving process, and so I don't know if you can see the floor down here, but we've got simulated zones. I'll try to use this. So there's a different level of intensity for the initial prescription. I'd probably tighten in just where in the zone of greatest problem, and I'd make sure that the prescription's giving me a positive effect there. And then every year is an experiment in farming. You get to expand that zone and really dial your prescription in and make sure it's working. So it'll be an evolving process.
Okay. How far apart would the dots be? Or I guess that would depend on your planter and some of the other technology too.
One of the cool things about SIMPAS, and you'll see it here, unlike a lot of I guess prescriptive applications that talk about section control, where they may be 20-foot sections, we've actually got individual row control here. So we can get pretty granular with delivery of the chemical if the prescription calls for it to be down that tight.
Okay. Finally then, you mentioned it isn't commercially available yet. What is the plan, or what's the timeline in terms of where this technology goes, or what's the next step there?
So we're really looking at full commercialization in 2020. So we may have a soft launch where I guess what we expect to have commercially viable equipment in 2019. So we'll be through the development process, but we'll keep it very small, trial that out there, because we don't want to use farmers as guinea pigs, but we'll have kind of reached a spot that we say we think this works, and then once that proves out in 2019, we'll go ahead and make the system available for sale in 2020. And we've just recently signed a memorandum of understanding with Trimble. We've got a lot of details to work out yet. We expect to have those details completed by the end of the year, but we anticipate Trimble being the distributor for SIMPAS equipment. So what we want to do is make sure that the equipment is available through a network of dealers that can provide support out there who wake up every day thinking about precision ag and making it work for farmers.
All right, very interesting. Thanks for your time.
Thank you.